Hello everyone, it's November 25th, but I'm doing November 26th for the daily challenge. I mean, it's still Thanksgiving, right? So tomorrow gonna have to travel a little bit, so might as well just get it done today. So tomorrow will be a little bit less stressful, traveling and flying and that type of stuff. So let's go for it. And I don't have two screens today, so it's only one screen. So I have to switch back and forth. Okay, we have today. Oh, we have an easy one today. Oh my god. Search, insert, position. I think because Thanksgiving they make everything easier. Man, I think I've done this more than once. No, only once. Oh wait, what? Is it 2018? Wow, that's 3 years ago. More than 3 years ago. 2018. Okay, what this one is about? Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it will be if that means it's going to be, so everything is distinct value. How about the given value? Oh, if the target is found. If not, return the index where it will be. I mean, this is just bisect, but no, if we want to do it, let's do it. Binary search, right? It's just binary search. I think I clicked the wrong button earlier. All right, so where are we? We're gonna do this. Yeah, once in a while, I should do binary search. Because binary search is tough to write if you don't know what you're doing. This is I shouldn't say tough to write. It's just a lot of edge cases. Okay. Oh, what did I do? Wrong button. All right, let's see. Binary search. So we have a target of a num, so we're gonna go low, high, right? So set up binary search. And then while low smaller than high, that's how I like to do it. Mid equals low plus high divided by 2, right? But we also need to know where to insert it. We want to know where it would be if it were inserted in order, right? So what we're gonna do, low smaller equal to high. So if return the index. So if num's mid, right, is equal to target, then return mid. Done. Otherwise, if num's mid is smaller than target, if num's mid is smaller than target, then we're gonna go higher. So low equals mid plus 1, else high equals mid. Right. So this one, when we get out, do we have the one larger? Do we have the one smaller? Let's think about it. So mid, right, is some value is smaller, then we move one higher, and then, right, and then is higher. So high. So I think just return low shall suffice. This makes me actually thinking. No, actually, I think this should be right. Oh, it's fine. Return low or high. Yeah, we're already biased towards a 1 plus 1, so that's fine. All right, so 1, 3, 5, 6. Okay, we have 1, 3, 5, 6 for all of them, and target is 5 should be 2. 2 should be 1. 7 should be 4. 0 should be 0. That is true. And 1 shall be 0. So we have 1. Target 0 is 0. However, none of them is found. We should have like 1 shall be 0, right? 3 shall be 1. 5 shall be 2. And 6 shall be 3. Alright? Okay. That's not S. Nums and target. Nums and target. What is this one? It's a search, insert, nums, target. Alright, we failed one of them. Let's see why. Number 2. 0, 1, 2. This one. 7. Answer is 4, but return is 3. I should do this. There we go. Okay. That shall be it. That shall work. Yep. There we go. So just binary search. This is binary search. Done many times. This is mine. Alright, so this is LeetCode 53, 35, 35. Binary search. That's a basic binary search. Right? And then it's all login. And we're running, how long are we running? 53 seconds, 29% ranking. I mean, there's another way to do it, is using bisect. So let's just try that. So import bisect, right? And which one you're going to use? Bisect. Oh, we have to check, right? We have to check. What about bisect right? Yeah, let's do bisect right. So we say indexing equal to bisect dot bisect right nums target, and we're going to say return index if nums index minus 1 is not equal to target, else index minus 1. Okay, try solution 2. Yep, I just want to be faster. I'm using bisect. Maybe that's the 44. Yeah, that's the 44. There we go. I'm pretty sure this is a bisect. No, it is not. It is actually, oh, it's the same. $48. Is it today? 53. Alright, so that's it. But let's roll another one. Alright, let's roll another one. Did you feel like it's faster today? I don't know. Good connection. Everything is faster. Maybe it's because this laptop is not able to drive 2 screens. Like I'm currently doing 1 screen and everything is as fast as I would like it to be. Alright, let's try this one. Different ways to add parentheses. Given a string expression of numbers, and operator return all possible results from computing all the different possible ways to group numbers and operators in order to answer any order. Ooh. So parentheses, like I can do parentheses at the front, minus 1, or 2 minus this, and yeah, and that's the only 2 ways to parenthesize this. So basically, each parentheses will group together based on operators, right? So each operator can be assigned a parentheses. So this operator assign, right? Or we can say this operator assign. So basically, which one assigned first? Let's try this one. Let's write it ourselves. I have a piece of paper. So we have 2 times 3 minus 4 times 5, right? So I say we're looking at the first, so we can do this first one, and then second one, right? Okay, second one, and then third one, right? That's one way. Or we can go first one, but don't do the second one, do the third one first, right? And then do the second one. Okay, that's it. That's all the possibilities. Now we're gonna go second one first. Okay, so second one first, and after we do that, we can go first one, and then third one, or second one first. We can go with the third one, and then go with the first one. The last chances, third one first, and then we can say the first one. That's actually repeats, but that's fine. Or third one, second one, and the first one. So in total, I have 1, 2, 3, 4, 5, 6 different possibilities. Not different, 6 possibilities, but 2 of them are the same. So we have 5 values, which is I can calculate it. Which is 10 minus 14 minus 10 minus 10 again. Oh, minus 10 again, yeah. How about this? This is 6 minus, that's minus 14. Oh, we cannot use results. It has to be the pattern. What's the last one? The last one is 20 minus 34. So minus 34, minus 14, minus 10, minus 10, and 10. And minus 14 appears once because minus 14, the 2 patterns are exactly the same. So, we have to also, okay, but, if we don't do, like, how do we identify, like, we know these 2 minus 10, they represent the exact same thing, right? The operation is the same, but the parentheses are arranged differently. Therefore, there are 2 different arrangements. So we need a way to identify the differences, right? So how do we identify differences? We need to use the string. So we do have to string it. We do have to string it in order to identify that it's a different pattern. Okay, so first thing in my mind is to grab the indices of the plus, minus, and the multiplication, right? So for this one, our indices is 0, 1, so we have position 1, 2, 3, 4, 5. So 1, 3, 5. And then we do a combination of 1, 3. Wait, it's a permutation. No, it's a permutation. So we do a permutation of 1, 3, 5, which give us 1, 3, 5 is 6. Exactly, or 6 different possibilities. So we have 6 possibilities. So this tells us, right? This permutation tells us which operator will get parentheses first. So we're gonna go 1, 3, 5, 1, 5, 3, right? 3, 1, 5, 3, 5, 1, 5, 1, 3, and 5, 3, 1. So for each permutation, we grab the operator out first. So for 1, so we grab it as a multiplication, right? And then we need to grab the value. How do we grab the value? Oh, we'll grab the value. You can see like left and right. Put that into put that into an array. So the original value, we put that into an array. Okay, so we put that into an array. Okay, we'll put that into the array. This will help us compute the value. Okay, so we put that into an array. So we have array, and every time we grab an operator, we always look left and right into the array. So we grab the value out. All right. So now we grab the value out, and we're going to compute the value and push that into, array will not work. We have to remove the entire thing. What type of data structure can we use for this? Like 2 times 3, right? I've done it. I want to remove the entire thing and then replace 6 into it. All right, that's what we want. Or if we want to compute 3 minus 4 first, we can just take out that part and then replace a single value into it. How do we do that? Well, maybe we don't. We just do the parentheses first. And once we do the parentheses, we can always compute the value from the parentheses. Okay, do we have an easier way to do parentheses? So, maybe. What if we grab this out? Let me think. Yeah, how do we add parentheses? It's a good question. I mean, the problem is the operator. We cannot get the operator easy. I want to get the operator. Yeah, so the first one, let's say, the first one is easy. We can grab it. And then the second one. How do we do the second one? I mean, I remember the expression is 20 in length, so it is possible. Once we grab it, we turn those into, sentinel values. We can do that, but how should I put it? I just feel weird. All right. Let's say we add parentheses, okay? Then what? Then I take out the minus sign, then look right and looking right and looking left. But so each parentheses will always be associated with, that's not necessary. That's not necessary. Yeah, so minus sign, then I'm going to take left and right. How do I know the left is a single entity? Okay, how about we have this unlocked to both sides and integers in the range of 0 to 99. Now this we can solve. We can turn the entire thing into an array. And while we're doing it, we can parse the numbers. That's fine. That's not an issue. So I parse the numbers, right? And then once we parse the numbers, once we parse the numbers and we pick them out and we create a new thing. So we create a 2 times 3 thing, okay, with parentheses, and put into a new array. Yeah, is that an array? It's just a thing. It's just a string, right? It's just a string. Okay, that's a string. And then what? Then in the original one, we need to, let's say, turn that into a sentinel. Right, so all the values we need to turn into sentinel. What is sentinel? 0 to 99 minus 1, right? So we turn that into minus 1 as sentinel. Now we're going to grab the minus sign. Okay, when I grab the minus sign, I'll look left and right. And left is minus 1, which means it's a sentinel. We don't take it. So the right, yeah, so by that, we know 4 need to be added to the right side, right? So we grab this, and then we say a minus sign, and we got a 4, right? Not a 4, just a value, and then put parentheses. And as we do this, we can compute the value as well, and then 4 will turn into minus 1. Okay, this might work. All right, let's try a more complicated. The 3 minus 4 will be go first. Okay, again, so 2, 3, 4, 5. So I'm going to grab 3 minus 4. So we've got minus sign, look left and right, all good. So coming out, 3 minus 4, and we record current value is minus 1. After we've done that, we will sentinel it. Next one we need to grab is, let's grab the second multiplication. So grab the second multiplication. And that one, looking left and right, left is minus 1, so we don't add to the left. The right is 5, so we know we need to add to the right. So given this, we add to the right times 5 and put parentheses, and that thing will result in minus 5, right? And that's minus 1. Third one is going to go to the left, so we're going to do 2 times parentheses. So this one will go to minus 10. Yeah, I think this will work. Let's grab it. So this is 241. 241. Okay. All right. 241. So we need to parse it first. Oh. Maybe recursion will be easier. It's like backtracking, right? Yeah, I should do this in backtracking fashion. Yeah, it should be backtracking. So def for backtrack. So I need to parse it. Let me parse it first, the expression. How do we parse it? We're gonna go exp, right? It's gonna be this, and for I in range, line expression, all right? We say if expression I is actually we're going to say for letter in expression. I don't have to, yeah, for letter in expression. And we say if a letter is in plus minus multiplication, then exp dot append letter. And then we're gonna have a num equal to 0, right? And else num equals, actually plus equals to 10 times num plus int letter, right? And then blah, next one blah, next one this, on this, we're gonna x dot append num first, right? Append a num first, then append the letter, and after that, num will go back to 0. So that's the parsing. All right. So before we do anything, let's do the parsing first. Just make sure that we go step by step. Every step is correct. So we have this, right? That's our first. The second one will be this. I might as well put the results in. This one was 0 and 2. Oh, this is complicated. Okay. So this will be expression. Diff ways to compute. There's a diff way to compute expression. What do we want? I just want to print. I just want to print expression. Okay. How about we go a little bit more complicated? Let's say 23, right, minus 45 times 67. Right? I don't know. I don't know the results for this. Actually, I do. So 23 minus 45. Oh my god. We can actually go for, let's go Google. So we have 23 minus 45 times 67. And this. What else can we surmise? Well, we can do 23 minus 45 times, actually I don't need parentheses for this one. Oh, this one's even smaller. So I'll have to put it here. Alright, let's see. Yep, it's good. It's good. Okay. So now we can backtracking. Alright, so let's do backtrack. Backtrack, what do we need backtrack for? Oh, we can, how do we backtrack? Blah, blah, blah. And then go back. Yeah. Well, we do need the indices, so I need expression. Right, we have expression and OP index. Right, so append this OP index dot append len exp minus 1. Right. Again, when to print expression and O operation index 0, 1, 2, 3. 0, 1, 2, 3. Yep, that's good. So we have these. Now we're going to backtrack on. Let's see, backtrack on OP index. So we have an index, another index, right? So the current one we're looking at. And then what? So how do we do permutation? So we grab the first one, right? And then we want a permutation of the remaining. So we get a permutation of, hold on. We grab the first one, then we take the second one, then we take the third one. All right, or we grab the first one, we take the second one, the third one. Hold on. How do we do permutation on this? Right? We grab the first one, that we call backtrack. Okay? Nah, so I don't feel comfortable doing that way. Because this one will say I do this first, right? And then I say I permutate for the remaining. Okay, so I grab my current index and I want to permutate the remaining. I need to permutate the remaining. Let me think. I grab the first one, right? And I say I will do the remaining. What will the remaining help me? The remaining will, but the first one shall be constructed first. The only reason doing this, I just don't want to create the copies of the expression every single time. That's the only reason I want to do like backtracking. I can reduce the amount of writing, copying basically. Can we do that? How do we do that? First one, okay. And then we go to the second one. Okay. And once we're done, we go to the third one. Okay. And once we're done, if we backtrack to the second one, and then backtrack to the first one, right? Can we just go to 5? How? Or it's not backtracking. We just create the permutation, right? And well, it is backtracking, but we use this backtracking idea, so we don't have to. Okay, so let's not call it backtrack. Let's just call it compute. Okay, let's call it compute, and we'll have indices. Indices will be OP index. All right, we're gonna do permutation of OP index, and we'll grab the OP index. So I can say OPI. Right, this is gonna be OPI, and we just go on to the next. The next OPI. Oh. Okay, so let's call it I. Permutation, right? So OP perm. That's going to be a list of integer. All right. And we're going to have a expression res equal to this. I don't have to return anything. So I is the index of OP perm, right? So OP perm will give me the permutation of the OP indices. OP index. I don't like OP index. It's called OP indices, right? Operator indices. And on the operator indices, we're gonna do permutation of them. All right, permutation of that. We'll get everything we pass in as a list, and we're gonna just go one by one. But we're gonna go one by one in the recursion format, such that we don't have to copy the expression every single time. Okay, so now we need to create. Oh, we do have to pass down current paren. Right, let's call it paren. Right, so paren. And with the first one, we grab I. Right, we have the index. So the operating index is O perm I, right? And hold on. If I is equal to length this, then oh shoot, we need the paren expstr, and we need exp, not result, exp value. So I have 2. And if this is this, then we say expression result expstr equals exp val. Right? Then that's it. Else, we're gonna grab the operator index, right? And then we're gonna check. We say, yeah, we grab the value. We say left equal to exp. Right? That's the parsed exp. Actually, that's also, don't call it exp. I don't like it. exp parsed. Right? Let's call it exp parsed. exp parsed. exp parsed. Len exp parsed. Blah 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 blah. Okay, so here is exp parsed OPI -1. Right? If this is equal to -1, that's the whatchamacallit. That is. Oh, we have 2 things. We have left str, right? So if it's a sentinel, then left will be expstr. If else, the str this. Alright, so there's a left str. So the exact same thing for right str equals this if this +1, right, is equal to -1. Else, we just do operation +1. Okay, so when I have left str, right str, next we need to say left int, right, or equal to exp val. So it's the same idea. It's the same idea. If this equals that, else we don't have to turn it into this. And right integer. Actually, this one will be more fitting. Equals val if this is this, ly, else y, we're going to do this. Okay, so we have str, we have int. All right. Then we simply call compute again. Oh, we do not call again. We need to first change. Did you change? Oh, this is just convoluted. I need to change all the numbers into -1, which is fine. Hold on, can we make this easier? This just feels very convoluted. Left integer is equal to exp parsed. Yeah, let's feel convoluted. Let's say left equals exp parsed OPI -1. Right will equal to exp parsed OPI +1. Right, so we have left and right, and then once we grab left and right, we're gonna set OPI -1 equals -1, and exp parsed OPI +1. So both set to -1, right? And then we're gonna call compute again, I +1, right? And this doesn't change. An expression, right? The expression is going to be this and this is important. Oh, it's a bit different. Actually, it's not different. Exp parsed. Anyway, I think this one will be if left. If left. If left is equal to -1. Alright, if left is -1, then what do you call compute? So left is -1. So what do we pass the next one? If left is -1, and then we need to say expstr, right? So that's going to be expstr and exp parse OPI, that's the operator, and the last one will be right. Right. Okay, and don't forget when we put the parentheses as well. This is here, this, and the value is going to be exp val, right? We need to also have OPs, right? So we say multiply equal to operator. So import operators. So this one will be operators.mul plus will be operators.add minus will be operators.minus. Is that minus? Operators. Nope, they don't have minus. Jeez. We have add. We have multiplication. Oh, it's sub. It's sub. It's not minus. It's sub. Right? And then we call sub AB is A minus B. So we have this is the expression, and this is the actual value. So it's going to be this with OP's XP parsed OPI, this one, and right. Okay, it's left equals -1, and of course we have also right equals -1. So elif right equals -1. These don't change. This one change. So this one will be left, this, and this parsed. Right? No, not right. This one will come in here. And this one will be parsed left and exp val. Okay? And else. That's neither than -1. So again, compute, same way. Let's see, add +1, OPPM. Now, this one is going to be left. And this, right, and right. Value just OPS. I'll copy this. Left and right. Huh? Just left and right. Right, left and right. I look this way. It feels, how should I put it? Convoluted, right? This is the same operation. If I can just say, yeah, that's why I want the left. How about do this? We say left str, right str. How about this? We say left str, right str. Well, that's left and right. Let me think. What would be the easier way to handle this? Left and the right. Okay. Let's say str left, str right, left val, right val equals left and right. Then we say if this, then left ftr equals to exp str, right? Left val will equal to exp val. Alright, and say elif, if the right is this, then right str equals exp str, right val equals exp val. Right, and then we don't have to do this. And there's no else, right? No else. And then we simply call compute, blah, and this is left str, right? We have left str, right str, and this is left val, right. I feel this is cleaner, right? So we compute, and after compute, we will redo this, right? So it's backtracking. So this is backtracking. So this is backtracking. So this blah blah equals left and right, right? Left and right. So now once we're done, we did not change exp parsed. That is important. Okay, so we compute. Now what? Now we just for init permutation. So from it tools import permutations. Okay, so we're gonna say for perm in permutations of what? Of OP indices, right? So OP indices that we simply call compute. Compute index is 0, right? Man, I just feel like all this could have done without, like, the only reason I do it is because backtracking. So I don't have to make copies every single time. But then you have all the stack. Yeah, you push on the stack. So, I don't know. Maybe. Anyway, so this has to be list perm. And expression will start with this. Value will start with this. So we do this. Now we return. Right, we return, just say exp rest of values, and turn that into a list. Okay. All right, let's try it. Expression, blah blah blah. Now this has to be sorted rest. No margin name operators. Really? Oh shoot! It's operator. No S. Hold on, something is wrong. Do it again. Operator. Okay, we have a list out of range. See, that's what I'm talking about. It's getting complicated. Why would list out of range? Oh, you don't start with 0. Yeah, you do start with 0. I get an OPI. All right, let me check this one. Yep, same thing. Okay, what will be out of range? Print I and this 0, 1, 2. Oh, hold on. I got 2. Okay, and yeah. So I have 2. So come in OPI. Hold up. Let's print OPI. Actually, let's print here. Print left, right, and OPI. Left, right, OPI. I think it. Oh, it got out here. What's OPI? OPI is. No, let's don't do here. Let's do here. Print OPI. Operator index. 135, right? It's 135. 0, 1, 2, 3, 4, 5. So I shall be able to do OPI plus 1. What's the EXP parsed? EXP parse, right? 0, 1, 2, 3, 4. Oh! We did not parse it. I thought I parsed it well. What? EXP parsed. I didn't push in the last one. Oops. Oopsie daisy. Ah, because I'll only push in if this. And on the last one will just be this. Oh, I just need to do exp parse dot append num at the end. Okay. Now these are all right. Then we have a different issue. Our issues is the result is not the same. Oh, wow. That's terrible. We got 10. Yeah, let's go sort it the rest. We don't have minus 14, and we have 7. How did that happen? 7? How do you even get 7? We can print. Let's print xp res. This is a y. We have a 1. Like, what the hell? What the hell is 1 doing here? If left is minus 1, then we do. No, it won't be both is minus 1. If left is not minus 1, I do this. If right is minus 1, I do this. Right? If left and right both are minus 1, how would both be minus 1? But apparently this is what happens. Both, so is 4 times 5 come out first? Oh, I think I know. Huh. Alright. I don't think there's another way. No, this one won't work. Because I set those to minus 1 already. And if I'm backtracking, I have to backtrack all the way to the front in order to change everything. You know what? Forget about it. Forget about it. No, I'm not backtracking anymore. I am just going to do good old copy. So we're gonna go this, right? And then we say exp copy equals exp parsed. I'll just copy it. And after copy it, I'm just going to go for OPI in perm. For permanent perm, I can do that. And I already have, so we're going to grab all of these. Grab all of these. Left and right will be, now these are not parsed. These are exp copy. So I will grab the copy and do blah blah, minus 1, minus 1. I can do this. Because I grabbed it, right? I grabbed it, and then I did it at the end. I grab it, and blah blah blah. If this, you know what? That's fine. Let's put it here. I grab it, and then we check left. I'll get it left, get it right. Blah blah. Handle this. After handle this, I just need to. Oh, we do need to have exp str and exp val. This and 0, right? So once it's done, we're going to just do exp str equals this, all right, and exp val equals this. Man, this problem is taking way longer than I want. How much time have we spent on it already? Wow, we spent on 59. Wow, this is not a difficult question. It took too long. And we blah blah blah, do all this. We don't have to do any of these. Right, no, any of these. Nor do we need to do this. And once we go through everyone, Then we simply say exp res exp str equals exp val, right? And that's should be it. Go again. That's the same failure. Yo, what the heck? Oh, because it's not parsed. We have these, have to change. They're not parsed. Copy. Alright. Blah, blah, blah. You gotta be kidding me. That's still not right. I copied it. Wow. EXP copy every single time. Yeah, it's the same value every single time. And left and right. And then we set this to -1. That's fine. And we do this. And print left, right. You know what? I don't print left and right. We can just print exp copy and OPI. So exp copy is 1, 3. Yeah, I already settles the -1. 5. Okay. 1. They look fine to me. Yeah, they do look fine to me. Oh, I see. This has to go at the end. Yes, I have to go at the end. Ah. I thought it go at the end. It's still not right. What the heck? Go at the end. It's still not right. Are you telling me we have same thing, OPI, right, and exp copy? Should be slightly different. OPI is 1, 3, 0, 1, 2, 3, 5, that's fine. 1, 5, 3, I had 3. 1, 0, 1, 5. Yeah, definitely one side is not. How? If left, or left and right. Oh, we do have -1, -1. How? 1, 3, 5, 1, 5, 5. Oh. Yes. Ah. That's his -1, -1. Okay. Okay, that's fine. That is fine. Now what value should we use? I mean, you shouldn't. So, if left is equal to -1 and right equal to -1, right? So they have all been considered. In that case, oh, that is, what should we do in that case? Yeah, so we go left first. Then we go right. And they already merge them together. Shoot. Yeah, you're right. But the expression itself doesn't really matter as much. We can just use the same way to create expression. That's fine. Do we have a better way to handle this? How about don't use a string? Let's use let's not use a string. Let's use a stack. Right? Okay, use a stack. So 2 times 3. Right? That's the expression, we put it in. And then minus 4, that's another expression, we put it in. And then times 5, that's another expression, put it in. And then we can turn that into a tuple. Right? The entire thing we can turn that into a tuple. Yeah, that could be a tuple. And then in this case, it's 2 times 3, that's the first part, a string. And then 4 times 5, that's the second part of the string. And then minus. This, and then minus, right? And this. Sometimes with times 5, sometimes. Okay, how about the value itself? Well, we also push the value in, right? So we pop 1 or pop 2. Okay. Changed my mind. So exp, I should say str, exp, I don't know what to call it. But it's not str. Both are stack. All right, and then when we grab it, we are gonna grab. In that case, yeah, we still need sentinel. Yes, we do. We still need sentinel, and so left and right, grab from exp copy, and we're gonna check left and right. If both are -1, all right, both are -1, then exp str dot append exp copy OPI, done. Right, and then exp val will equal to exp val 0. That's going to be OPS exp copy OPI exp val 1. So we redo exp val, right? And then elif. Left is -1, right? If left is -1, that means we can do, what do we do? That means we do exp str well, exp str, hold on. Simply append, right? And exp str dot append. Not really dot append. Shall equal to maybe, hold on. Let me think. No, ESP, this can still be this. That's fine. So we can just say plus equal to this. Alright. Otherwise, ESP_str is going to be, if left is -1, so we need to put the left, so equals to ESP_str plus right. Which, let's just be honest, let's just use this. Equal to this thing. Now left ftr, left is just exp. No, it's left str. Alright? And, well, in that case, we probably don't need these two. Yeah. So yes, str was equal to left, because left is -1. No. As left is this, and the right. Alright? And exp val will equal to, want to grab it out, compute, and push it back in. Okay? So it's still going to be this. And it's going to be OPS. Let's copy OPI. And this one. exp val 0, because only one value. Now left is -1, and the right. That's it. It's -1. Or right equals -1. So it's the same thing. Alright, same thing. But it's going to be left. This is going to be exp_str. And this value is going to be left. And this. Right? Else, neither is -1. If neither is -1, then exp_str simply plus equal to this. Right? We're going to plus equal to this and right. And exp val dot append. Right? Append this thing. And this is not here, this is going to be right. And we don't need any of these except it has to be turned to -1 when we're done. And once we're done, this is this. Okay? Let's try this one. Is it correct? Just we have to do 0. Oh, it's still not right. What? I have a positive 14. Wait, what the heck? Positive 14. Both -1. Oh. We have to, I think it's going to be pop and pop. Okay. So it's going to be pop and pop. Yeah, let's use pop. Instead of calling this, I just call pop. Alright, so this is a, it is a, oh, it was still not right. What the heck? Pop doesn't work, man. How? Okay, pop does not work. The problem is, there's a minus. Now we need to know which one's left, which one's right. Which actually boils down to this, right? If I boil down to this, I have left I have right. It's based on left and right, and if I do the first one first, then the first one will go in first, and the second one first, the second one going first. Yeah. Oh, this is. Hold on, let me think. The order matters. I have an expression. All right. How do we decide which one? Yeah, that can go third, right? I compute. Yeah, that does put in to order. Order. That's what we need. Order. Whoever is encountered first. You know what? The problem is not who is encountered first. The problem is when we compute which one shall be the first, which one shall be the second. Now, in any of these cases, if one side is -1, right, then we know which one's left, which one's right, because one side is -1, and we can adjust. So this condition is correct, and this condition is correct. And when both is positive, we also have left and right. So the problem is here, right? We don't know how, because both are -1. We don't know which one should we go first, which one should we go the second. Now, how do we know? This is because the operator, so the left and the right both are done. But in which order the left and right are done, we do not know, right? So to solve this problem, if when we set, instead of setting -1, we set them to a value. Actually, we set them to a value is not going to help, right? We need to set we know it's on the left, we know it's on the right. But what we do not know is in the exp val, right? When we push into the exp val, the one with a smaller shall go first. No, that's not what I'm talking about. What I'm talking about is the exp val will have two values, right? We just need them to be in order, which means when we push in, right? When we push in addition to the value itself, right? In addition to the value itself, I would also want to push in the position, right? The position. So now if I have the position, when I get out, I can use the position to determine which one will go first, which one will go second. Okay? Alright, let's try this. This is getting more and more convoluted. Anyway, and I also want to do this. I have to repeat this one every single time. Alright? So I have OP, so all these can be simplified to OP. Okay, but exp val will equal to, it's going to be a tuple now. As the value, but in addition to the value, I would also want to obtain. Oh, then expstr is also going to be more complicated. Damn. Okay, so we want to put OPI then, right? OPI will indicate its position. So everything will become, oh my god. So this is going to be this, right? Because we can't just do left OP right. No, we cannot. So the same OPI in index, right? So we just add index to it, okay? It's fine. Let's just add index to it. So this can be this, and we add index. Same thing here. Add index. Okay, so these are the simple case. Now this case, is here, this can be append, right? This and OPI, this. The same thing with OPI. Alright. So now, when both are -1, right? When both are -1, we cannot do that. We have to sort it, right? So when both are -1, we're going to sort exp res. Well, in that case, I should put OPI at the front. Damn. I have to do this all over again. Jesus. Alright, so we're going to do... No. Yeah, it's not working. OPI at the front, so I can sort it without supplying the key. It will sort based on the first value. Alright, so OPI, and this one same, OPI, and OPI. Alright, now I'm going to sort this. I'm going to sort this, and after I sort it, I can do expstr. That will equal to this again, and have this OPI something. What is this something? This something is if blah blah blah, right? So first blah is exp. Oh, it's not res. Come on, str. So str because I sorted it, so I can go 0 and op and expstr 1. All right. And the same thing, we're going to sort the value as well. So sort the value. After I sort the value, we are going to do... What are we going to do? We're going to go OPI, val 0, 0, and val 1. So this is in order. Alright, so blah and blah, this and this. And once we're done, we're gonna go, we can pop, that's fine. Oh, the heck. Where? Unstable operator minus for tuple and int. Oh, I think I Wait, which line? Line 35. Yeah. exp_val.pop. Ah, that's true. Oh, shoot. Right is a value. Pop is a tuple. Exactly. Pop is a tuple. Tuple should be 1. All the pop. Oh my god. Okay, these are fine. This is actually not fine. I just realized like a 0 is a tuple, right? So a tuple and grab 1. Everybody need to grab 1. Same thing, grab 1. Same thing, grab 1. Enable the hash. That's true, because I forgot to go 1. Huh? How is 1 a list? The heck? This grows so complicated, I can't even reason with it. What the pop? Question is a tuple. Alright, the value is a tuple. Pop out, it should be the value. What? exp_val. Let's see. What do we get? Yeah. 5 and 10. So I say exp_val.pop. And grab 1 should be 10. Oh, exp_str. Jesus. Same thing. .pop 1. Sort is not defined. Of course, sort is not defined. You want to sort in place? Yeah, let's sort in place. I don't know why I do the other way around. Of course, sort is not defined. Oh my goodness. Huh? Less than int. What are we having? Oh. How? Oh. What? Oh my god, this is this is terrible. I got 10 minus 14. I don't have 34. I just have minus 17, minus 17. What? Something is not right. Something is not right. Okay, some problem I already see, so this is a problem. I don't like pop. So I just do 1-on-1. Okay, everything is going to be 1 and 1. No, I thought 0, 1. 0, 0. Again. Index out of range. Of course, index out of range. It's a 0. Oh my god. Another index out of range. Okay. That's even more wrong. It's -2, -2, -2. Wait, what? That is... This is 3 minus 4, right? And 2, that's -1. We got a -2. I think the last one did not go as planned. So we'll be right as -1, yeah? Okay, right as -1. So, this one's correct. And, oh, I see. I see. Typo. Enjoy. There we go. Oh my god. Oh my god. Talking about convoluted. Man, this is so okay. Parsing, we need, right? We have to parse. This is needed. Permutation is needed. And I have the copy because I need to put sentinels in. And these are 2 stacks. And we got left and right. We got OP. Alright, let's put them in one line. Because they belong together. Right? They belong together. So left and right. I said both -1. I need to sort it to grab it, sort, grab it. Otherwise, grab. Otherwise, append. And then we set this to -1 as sentinels. Yes. And eventually we grab this. Okay. Oh my god. How? I mean, it could be our computer wrong, so I'm gonna just double check. Alright, so it's a 2, 3, 4, 5. So it's 2, 3. Yeah, 4, 5, 6, 7. Jeez. Yeah, 2, 2, 5, 4, 9. Oh, 10 times num. My bad. It was a parsing error. Okay. Man, didn't expect to spend that much time on this. Jeez. Not happy at all. Like, it's more than an hour. An hour and a half just on this one. Jesus. It's not a difficult one. Again, it's not difficult. And hopefully there's no edge case. Runtime error. What? Oh, expression. Okay. So what if this? 0? Is that a 0? Yeah, expression is 0, so it's a 0. I mean, can we have, I don't know, 2 minus? I don't know, return 2? I don't know. Not a valid expression. So either a single value or is no operators. So blah blah blah. Then we do what? Then we say if not this, simply return exp parsed. All right. It's edge case. We say edge case where no operators exist in expression. One more time. Okay, go. Come on. Alright, this is different. Alright, that's what I need to investigate. I don't know. I don't know the result of this, so I'm gonna have to try it. Did not sort it. Shoot. Sort. Okay, let's see. Let's see what happened. Index out of range. Index out of range. So for this in perm, this line out of range. So we have left and right, both is -1. Okay. And then there is only one expression inside. I think that's what it is. There's only one expression. How would there be only one expression if both is -1? If I go this first, this is -1. And I go this, -1. If I go this, I have 2. If I go this, that's also -1, -1. Then I go this. How? What should I do? Print OPI, so we know where they are, and print OPI and exp copy. So that's the last one, exp. OPI 0, 1, 2, 3. So that's 3. And left and right is -1. They are all -1. Everybody is -1. Hey, 1, 5, 7. I think that's the thing. 1, 5, 7, 3. So 1. 5 is this one, right? 0, 1, 2, 3, 4, 5. 7. And 3. 0, 1, 2, 3. So this one shall be able to handle the result. Okay, so not only this, I also want exp str and exp val. Okay, let's see. exp str is currently we are at the 7th position. Because so 1, 5, 1 position. After 5, yes. All right, so I have 1 position, 2 minus 1, 5 position, 1 minus 1. And we'll have the value as well. So now it's 7. So 0, 1, 2, 3, 4, 5, 6, 7. So this one, right? This one. This one. Oh. It needs to go with Oh my god. It needs to go. Oh. I want to redesign the entire thing. And not only redesign the entire thing, I also want to keep it sorted. Okay? So I keep it sorted. So every time we are going to sort the expression and sort the value, and it will be very fast because it's only at most 20. Actually, it won't even reach 20. So every time 7 comes in, right? I need to find the one that's, because these are the expressions that's already in there. If there's only one expression, then that's it. Easy. We just grab this one, and depending on where it is, it's 1. The index will tell us where it is. Now, if it's a 7, and we have multiple, we need to find where it is inside, right? Yeah. So, I'm gonna redo this entire thing. Jeez. Okay, how do we redo it? So I have a left, right, and operation, right? And then we need to sort. So we're gonna call this everything at the beginning. We're gonna sort. We grab left or right. We sort, and we sort. All right, we sort them. After we sort them, we are going to check. All right, so these two are the same. Yeah, these two are the same. Hold on. Maybe we only need to keep indices. We keep one indices, right? Keep one index. And man, if we keep index, then we have to remove. Do we have to remove? Yeah, we do have to remove if it's in the center, right? We have to remove. We need to remove. Then the best situation is not map. How about this? We do a map, right? And we say the operator, right? And then we check the map. If not map, that means it's an if not exp map, expression map. If the map is not there, then we do exp map, right? OPI equal to a what? A tuple, right? So the first value of the tuple is the str, right? So will be this, the str. Second will be the value, which is this. No, not this. This. Okay. So if not map, that's the first value that goes in. Okay. Else, we have a map. Then we need to sort and then bisect it. Okay. From import, right? When import bisect. How do we do bisect? We're gonna do else index will equal to bisect right. Doesn't matter. And then sort it exp map. right? And your OPI. This one will give me, oh, I do need to say sorted OPI will equal to sorted exp map, and then this one will just be sorted OPI. So now this index will tell me where I should insert, right? So this value -1 will be the operator that I shall interact with. Where is it? No, hold on. I have a bunch of operator indices in there. So now mine coming in, right? Mine coming in. How should I interact? There's a new operator coming in. So the new operator coming in, if my operator is in between two values, in between two, so I grab those two, right? Otherwise, I grab the one that's nearest to me. Is that true? Yes, that's true. We grab the one nearest to me. Otherwise, okay. No, we can handle. We can say have an index. If index is equal to 0, right? That means my operator is the front, so I need to grab the left, right? So we can say sorted. No, not sorted. Exp map. I need to add me, right? Hold on. This is very delicate, very delicate. So if it's 0, right? So means we're gonna do current 0. So I'm gonna say right will equal to ri will equal to sorted OPI 0. All right, and then when I'm going to the map, I think I can call pop, right? Dictionary has pop. The dictionary has pop. Say 1, 1, 2, 2, 3, 3. I can pop. Yeah, I can pop. Param, so pop 2. Boom, 2 comes out. And an A, yeah, I can pop. So all I need to do is pop. How do I pop? I say, when we pop out, it's going to be expstr, right? And exp val equals to exp map dot pop. This is key, right? So when pop out, then I know mine is 0, so I'm going to use the left, right? So I'm going to use the left. So we're going to say exp map OPI equal to, so we're going to do the exact same thing here, but change the right into exp str, and of course this is exp val. But that's if elif index is equal to, let's say, len sorted OPI, so we have to add 1 to the end. In that case, same thing, -1, right? So we pop this one out, and then this will equal to the left. No left, left is the expstr, and this is right, and then this is the exp val, this is right. Else, that means index is in between, right? Somewhere in between. So somewhere in between, then we need to take both out, right? In that case, I do see it's possible. Alright, it's in the middle. Now I'll redefine left and right. Right, in that case, I just have to redefine left and right. Hold on. Hold on, we can actually do this. If not, left and right equals this. This, I would like to have this at the end. So here, we only need to do OP. Right, OP, operator. If not, left and right, perfect. Otherwise, we'll do blah, blah, and this, then we are going to say this is, we have str. I don't like it. I don't like it. I don't like it. I do not like it. But that's fine. Yeah, I do not like it at all. But there's nothing we can do. Yeah, let's do this. Do this. Do this. That's a plus. And do this. That's a plus. Okay. Alright. That's it. And then we do this. Blah blah. And here we're gonna go left and right. Alright, so basically this is left. This is right. Right, this is the right str and right vowel. Alright. And we're gonna say left str, left vowel equals to this and this. Right, equal to this and this. We don't need this one. So same thing. When I say left str and the left vowel equals to, pop it out, and this is just going to be right or equal to this. Actually, I can do this. Equal, equal, equal. Equal, equal, equal. Okay? All right. Now, this is going to be left str, right str, operation going to be left vowel and a right vowel. Okay, so here is index is in the middle, right? Index is the middle. Now we can just do 2 rounds of pop. Right, left pop, and I'm going to pop again, but we're going to pop to the left because in here's the index -1. That's pop left, and index is pop right. So we pop left and right, and once we pop, we get this, and we add this again. Okay. All right. So with this, we don't have to sort. We don't have to do any of these. So none of these is necessary. Right? None of these is necessary. Everything is ordered by their index. So once we're done, what's happening once we're done. Once we're done, we need to say once we're done, right? Because I pop one and add a new one. So I pop one, add a new one, or two, add one. So eventually, EXMAP shall have only one value, right? EXMAP shall have one value, which is index and the actual value. So I can just do pop, right? Yeah, I can just do expstr, because I don't think I referenced expstr before. And expval shall equal to expmap dot pop. Let's see, a dot pop. Ooh, I cannot do that. I cannot do that. Then what should I do? Items. Probably listed. All right, let's say a dot pop one. All right, so a have one thing. A dot items. Okay, how about I say key v equals a dot items. How about list a dot items? Not enough. How do we get? Well, I can say for kv in a dot items. So print kv. Yep, I can do that. Yeah, that's stupid. Alright, that's quite stupid. What do I do? I mean, I can say, I don't want to write a loop. Alright. For kv in, it's another item. There's only one value. So I'm going to say this is a key, and this is a v. expstr is not defined. Where? expstr. Why are you even there? I don't need you. Okay, that is not correct. Hold on, print kv key value. Oh shoot! Oh, the values. I just need values, right? And this is at the end of each permutation, right? So each perm, and at the end we have values. And the value shall be, get this out. Expression, right? So exp str and exp value, and yeah, it's not a key. My bad. It's going to be exp str exp val. Right, almost there. sorted. Let's see what goes wrong. -2, bunch of zeros, and oh, I think I have 1 fewer 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I missed a few twos. Jeez, wow, this one is not easy. Wow. I mean, apparently the error is expression, right? I mean, in total, you want to try expstr, xpval. How many? So we have 1, 2, 3, 4. 4. So 4. If we 24. Yeah. So we have 24. That's exactly the case. We have 24 and -2. We got it. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 twos. And we just need to, because the zeros are right. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 2. So we're going to remove -2 and all the zeros. Hold on. So all these zeros. Right, so all of these can remove because they are correct. So now once we remove, I remove 4 as well. 4 is correct. So we got these. I only have 1, 2, 3, 4, 5. 6. That shall be 6. Hold on, 1. So these two are the same. Okay. These two are the same. Oh, I say this and this are the same. And I say this and this are the same. Problem. Okay. We need a debugging not happening here. Debugging should happen here. So I can know the, so we're gonna print what? Print perm expstr and expval. Okay, now we have permutation. Okay, and the same thing. When the -2 can remove 4, we can remove all the zeros. We can remove, and we are having a rest is just okay. Now we're gonna do manually. What is it? 2 minus 1 minus 1 minus 1 minus 1. Okay. In total, we have 1, 2, 3, 4, 5, 6, 7, 8. So we can only have 2 pairs that are the same. All right. So 1. So this is 1, 3, 1, 2, 3, 4, 5, 7. So first one is 1, 3, 7, 5. 1, 3, 7. All right, and 5. Let's see. Oh, that is not correct. 1375 is not correct. All right, let's analyze. 1375 is not correct. So I sort, right? Then, so 137. Oh, shoot. When we do 7, we have 1 inside. 3 is in this. Oh, 7 we cannot. Oh, 7 is grouped with. I see. I see what's wrong. My God. I see what's wrong. Man. 7 has to happen. We're going to push a 7 in, right? 7. Let me think. So we grab the OP. We have OPI, right? If not, this one is correct. And I can sort it, that's fine. And then I need to check OPI if its previous and its next have all been included. All right? Then I need to sort. Then I don't need to sort. No, wait, hold on. I do need to sort. But still, I remove it. I remove. Once I grab it, I will remove it. Like if this goes first, that will be here. That because this will be removed. Now I use this to represent this thing. All right. So still. It is necessary. It is necessary. Oh God. To check -1. I have to check -1. Otherwise, yeah, this shall only be used when there's no -1. Okay. It's fine. So again, check -1. We say if exp copy opi -1 is equal to -1 and exp copy opi +1 is equal to -1. If both are equal to -1, then we do this whole thing. Right? If they're both -1, oh my God. If they're both -1, so the front and back both -1, that means I need to look into something has been done before to check. Right? Yeah, I have checked. I've checked this. You know what? I don't like it. I don't. This whole thing is just it's too convoluted. I don't like it. I don't like it at all. I think this one shall be right. If both are -1, right, then I do whatever it is. I would do whatever it is. Well, if both are -1, then this will not happen, right? So we can just do this. If both are -1, else if one of them is -1. So the left, let's say, if the left one is -1, right? This is left is -1, and right is not -1. In that case, right, the left is -1. The right is not. So an operator, the left already done. The right has not been done yet. So in that case, what do we do? We sort, right? We sort and we grab the index. Okay. Yeah. If both are -1, then I go inside and look for it. But hold on. What was the problem again? The problem is I have 1, I have 3, right? And then it's the last one. When I say if it's the last one, the right value. Oh, it's actually not the right value. Yeah, if one side is -1, then I shall always grab. Hold on. If 1, 3, 7, both sides are non-1. If both sides are non-1, I should just push this one in. If one side is -1, hold on. This shall happen if this or this. Any side is -1. I'll do this. All right? If any side is -1, then if any side is -1, so one side will be in it, and the other side is not. So we can actually do this, right? I can use this and say if it's 0, that means it must be the right side is in the -1, the left side is not, because I'm pushing. So that's that. Else, right? This else means both sides. So if this is -1 or this is not -1, so neither sides are -1. In that case, I shall just add to it, because in the original logic, this will also be doing here, but now it's different. Exactly. This is what we have. Okay. If I run this, oh, what the hell? That is not what I expect. Hold on. It's because you did not set to -1, right? Okay, so at the end, we need to set both to -1. So we can set at the end, we set this equals this equals -1. Yeah, we still fail. We have two -2s. 6 zeros, 1, 2, 3, 4, 5, 6, 7 2s, and 1 4. Yeah, I have some weird things going on. Okay, it's fine, it's fine. OP this will equal to this. Operator this means neither sides are -1. Okay, neither sides are -1. We'll grab this and grab this, push this whole thing, right, into it, and OP this and this, which is fine, right? We're talking about 1375. 1375 is correct. So what is not correct? 1735. Okay, 1735 is not correct. 1 7 1 7. Okay. Now 3. Oh my god. 3. The left is -1. So 3. The left is -1. But I will go inside this. You're correct. You're correct. This has to be both. Is this? If this is this, then we'll sort. Yeah, we have to do this anyway, right? Okay, both are -1. Now we need to sort. If one of them is -1, I still have to sort. You always have to sort, right? Okay, so if one of them is -1, I sort, and I sort will find out where I am, right? Because the right is -1, I sort, I find out where I am. I just need to know which one I need to deal with, right? If both are -1, that means there are at least 2, so I can go right ahead. I use that. If one of them is -1, then if one of them is -1, if the left is -1, but my right is not, then I need to find out what is my left. Just the one smaller than me. Right? Find the operator smaller than me. So I have my index, so my index -1. index minus 1. Okay, so it's saying always do this. Hold on. If both are minus 1, okay, if this or this, let me say if again, right? So this we sort the both -1, then we simply do this. Okay, so both, then we do this. That's right. Elif if the left is equal to -1 and else the right is equal to -1. Okay, so if the left is -1, then it gotta be something on the left, right? So again, I can do this, but it gotta be something on the left. Something on the left will be, so the left is -1, so the left will be this. Will be index -1. Right, there'll be something on the left, but the right is going to be copy. Copy, right? OPI +1. On the right side, because the left side is -1, and the right side is not. And else, same as this, well, similar, but this is going to be equal to this, equals this, -1, that's the left, right? -1, so the left is not -1, right? So for the left, we take it, and the right, we will do index by itself. And once we're done with all this, we're going to do this, right? Else, if both are 1, then we just do this. All right. This one pass. This one finally pass. Try the others. Oh my lord. I think this one finally got it. I think that's what I said last time. Go. Oh, God. Terrible runtime. Oh, wow. This is how long we took? 2 hours and 24 minutes. That's tough. Oh, this was very tough. Very, very tough. Alright, this is a tough one for me. This is a tough one for me. So I first parse the expression, right? I first parse the expression, then I locate the indices for each operator, right? For each operator. After that, I permute the operator indices. I permute the operator indices, and for each permutation, I compute the parenthesized expression and result. Now the difficult part is the parenthesization. Yeah. My method is to keep a how should I say? To keep a dict of not to keep track of the current parenthesization state, right? State of the expression str and the value, the computed value, and the computed value, current parenthesization state of this, right? And in addition, I also use sentinel value to indicate or whether a new expression shall come from the original expression or the states currently saved in the dict. Well, this is not really a good explanation, but that's what it says. Runtime, permutation. What's the permutation runtime? I don't know. Permutation. So the O, shouldn't that be permutation? Because that many times, right? I think times n. It's very bad. It's 320. I'm actually not sure if this is correct. But only 5%. Jesus, 5% ranking. Oh. But we did do it. So that's that. Terrible, terrible runtime. Alright. We have to check the discussion. And then put this list. This is a nightmare. Very difficult for me. Alright, I'm going to check discussion. 1 to 11 lines of Python. Recursion. Oof. Yeah, pretty much. I think it is recursion. Okay, let's see. A linked list. Huh. So, different ways to compute. Return a new linked list. Okay. To the length of input. Okay. If this is blah blah blah, then string part 1 is 0 to this. String part 2 is the remaining. And I will get a part 1 and a part 2. And for part 1 and part 2, I will compute. And once I compute, value of input, and then return. Okay, so let's think. I will go, once the first time I encounter a value, I will do recursion on the front and on the back, right? The front and on the back. What does this return give me? This return gives me all possible. all possible ways to add parentheses, so all possible results. And the front will give me all possible results. And then I simply, with each possible results can, oh, God, so good. So good, I know. Oh, there's a spaghetti code that can be simplified like this expression, right? So we just say expression. Return value is this for I, actually for I, E in enumerate expression, right? If E in this, I like to have these operators. If E is in this, right, then we say res L equal to self diff expression all the way to I, and then res right equals self diff expression I plus 1 to the end. And once we grab these two, right, this one, once we grab these two, maybe we can even cache this. How about the return value as a list? I don't know, maybe we can. This one we grab this. Here we have this and this, right? So anyway, so we got the left and the right, and then we just need to, each left and right we need to compute, right? And then compute the value push into the rest. So I'm going to say for I in for RL in res left, for R in res R, res.append OP E R left RR. And I just realized this I can do this. This I can do this. So we'll go left, we go right, and I push in. And then I say, once we're done, right? Return res, if res, else, int expression. Wow. And I think I can do this. So from func tools, import LRU cache. I think I can cache this. Add LRU cache, max size equals none. Extremely good recursion. Reference. Wow, this is so good. So good. Yeah, it is. Just a few lines. Right? Just a few lines. I run the code. Oh, oof, oof. I think the runtime is, well, we have to go through every single one, so ON. right? And everyone we go left and right. Actually, I don't know. What's the runtime on this? Maybe it's 2 to the n. Yeah, I don't think this is true. I think it's 2 to the n to compute permutation. That's not right. Just it's 42. My God. Oh, what a journey. All right, that'll be it. Wow, spent a long time on the medium. Yeah, this one is hard for me. Very, very hard. All right, see you guys tomorrow.